Thank you everyone for joining for this, I would say spring. I think, are we officially in spring? The spring edition of a GraphGeeks talk with Clair Sullivan, and it's about ensuring success for your graph team. Clair and I have worked together in the past at Neo4j. Clair is now doing consulting and has her own consulting agency. And I'll let Clair go ahead and give a full introduction of her background, and then I'll get started with her talk.
Well, thank you, Amy, for inviting me to do this. It's great to see you again. Like she said, my name is Clair Sullivan, and I recently left the world of corporate to start my own company, Clair Sullivan and Associates. I don't know why there's plural associates there, because it's basically just me right now, just getting this started. So when Amy and I talked, we thought it might be fun to have a talk that's kind of based off of a talk I gave at Day to Day Texas a few months ago, but with a graph spin on it. So there's going to be some content that is kind of more generically applicable to people working in data, and then I'm going to bring out, where the specific graph implications are here. So, Amy, you're still seeing my slides?
We are. They look great.
All right. So just really some quick housekeeping. First off, there's that QR code there. If that's useful to you, you can use that to go get a copy of these slides, or you can go to my GitHub, and this is just kind of like the main landing page for my GitHub. But if you go in there, there's a section on talks and presentations, and the bullet right at the very top is this talk. You click on that link and it will take you to the slides. So, don't feel that you need to be screenshotting everything, because it's all available online. Okay, so let's talk about what we're going to do today. First, just talking about data teams in general and graph teams and the lack of success that they've been having, because the title here, ensuring success for your graph teams, that kind of has the implication of, wait a second, teams are not successful. So we're going to talk a little bit about where some stats around the success or lack thereof around data teams. And I'm going to turn this into a bit of a story here that when I've presented this story to people, it resonates with a lot of people in very unfortunate ways, and you'll understand when we get there. And I'm going to talk about how this story leads us into looking at how data teams and graph teams are kind of approaching the world in this upside down way, and what the implications what those implications are for how we fix that, with one little sneak preview of where I feel like the world might be going, in my wonderful ability to predict the future. So let's just dive right in. And I will tell you, I'm not able to see my screen right now with Q&A. So if you have questions, let's try to save them for the end, unless there's some burning thing here. Amy said she's going to be watching the question section, so she can always dive in here. But these are just some stats here that we can go through, and these are pulled from various places, and they're all, I've got references to all of these things, but just some stats on the success of data teams. This is taken from a survey of Fortune 1000 companies, and they had a pretty diverse representation of types of companies. They had the executives, the data executives, responding to these surveys about how is data going within their company. And of the companies that responded, of which of the Fortune 1000 companies, 116 of them responded. So, it's a reasonable sample set. 82.6% of companies have a chief data officer, but only 40.5% of them say they know what that role should be. You've got 88% saying that they are increasing their spending in data, and 40% say that data modernization is their highest priority expenditure, which for us as graph folk, I think that's probably a good sign. 23.9% say that they are data driven, which that seems like a low number to me. 20.6% say they have a developed data culture. We'll talk about what that means in a minute. And about 80% say cultural issues are their greatest hurdle for deriving business value. And one of these things that I find interesting is 1.6% say creating data literacy is a top investment need. So we've got a data culture problem, but we're not investing money in making our employees more data literate and having them understand what data is and how it can benefit them. So those are some scary numbers. Less than half of an organization's structured data is being used in making decisions, which you of course know that means that unstructured data, and I kind of think of graphs in an unstructured way, even though, I mean, I could make both arguments here, but less than 1% of unstructured data is even being used at all. You know, these are just kind of some scary numbers here, but it's going to get at like this really scary slide, which is that 87% of data science projects never make it to production. And if you ask me, what's a successful data science project? It's one that's in production. And 87% are not getting there. They're just like, we're just wasting money. We're wasting time. We're upsetting people. These are really scary numbers. And it really should give us as a community pause as to what's going on in business that's resulting in such horrible adoption of data products. And so this is going to bring me to this book here. Now, you may or may not be familiar with this book. I'm in the process of working on my MBA right now, and this is a classic book in organizational communication, The 5 Dysfunctions of a Team. If you haven't read it, I really think this should be mandatory reading for like everybody. But the way that Lencioni here describes the communication breakdowns is through making up a story, and it's the Lencioni's fable, they call it. So I decided to create a data fable that describes what I see happening in a lot of companies today. And I will tell you, like I said, there are no associates associated with Clair Sullivan and Associates. It means that my marketing people did not create these slides because I don't have marketing people. And I also didn't have a huge budget. So we have wonderful graphics that go with these slides. I hope you like my graphics. Okay, so this is my data fable that I've created. And I've seen this story play out countless times. Places that I've worked, places that colleagues have worked. I've had random strangers on the street come up to me and say, oh my gosh, your talk on the data fable, that just like hit really close to home. Okay, so here it goes. We've got this CEO, and the CEO says, wait a second, all of my competitors are getting data scientists, and if I want to remain competitive, I have to as well. Now, you could replace data scientists with graph people, but you know, we're going to keep this, we're going to start by keeping it fairly broad, and then we're going to kind of hone in on it here. So the CEO is like, oh shoot, gotta go get me some data people. All right, so the CEO goes to HR and says, please hire me some data scientists, but HR person says, but what's a data scientist? And then they have this conversation about data scientists all have to have PhDs and be experts in natural language processing. And they've heard of PyTorch. So of course, have to have at least 10 years of experience of that. PyTorch has not existed for 10 years, but I actually have seen that in a job posting. Somebody said at least 10 years of experience in PyTorch. I love it. Okay, so we're having this conversation here now, and nobody really knows what it is that they want, but you know, we're going to go find them. Okay. So then they find some data scientists and they hire this team. All right, we're ready to get started. They're super excited and enthusiastic, and they come in. All right, who's my manager? I need some mentoring. What am I going to work on? Who's our PM? Okay. So CEO didn't expect that. So the data scientists didn't get answers to those questions, and so they're not. These are our sad data scientists. They're not real happy, and then they're trying to say, okay, well, what could we work on? And then they get together and they're like, okay, where's the data? More sad data scientists, because IT has said, no, you can't have access to that data. There's stuff in there that could be sensitive, but we can't give it to you without a business need, and that results in data scientist tears, very sad data scientists. So then the IT team says, well, but here's an Excel spreadsheet that you could use. Isn't that great? Yeah, no. So we got more data scientist tears. And then the data scientists say, wait a second, I have an idea. We're going to create this pipeline and collect this type of data. And then we could do something with it. And they jump through all of these hoops and they see billions of different permissions to create this pipeline, but they're not data engineers, they're data scientists. So they're not really efficient at creating pipelines, but they need one. And so they're going to do it, but it's going to take a little while because they're not data engineers, but all right, they get usable data. And now the magic starts happening. The magic smoke starts leaving the computer because the computers are working so hard because they've now started getting to do the thing that they're good at, which is modeling. And yay, they've created something and they're really excited about it, but they don't have a champion anywhere. They've created this thing that they think is going to be great. And so now they got to spend all this time getting on people's calendars, being like, hey, look what I made you. Isn't this cool? Don't you love it? Yeah, but like, then the people don't really get it. And the people aren't excited about it. And now we have more data scientist tiers. And so now what's going to happen is the CEO is going to get mad because data scientists are not cheap people. There's a lot of money that gets invested in data scientists and in data functions. And the CEO is like, wait a second, I'm not getting anything for this money. Where's my return on the investment? Okay, so then the data scientists all start leaving the company, whether it's, because they've decided to leave or because management has decided we're just wasting money here. There's no satisfaction. There's no growth for them. There's no long-term prospects at the company. And so where does this all end as CEO tiers? Okay, so I hope you liked the data fable and my very expensive high quality graphics there. Let's piece this story apart now. Okay, so, it started with this CEO wanting to get these data scientists for no real good reason. Okay, there was no business problem that the CEO identified that was a data problem. The CEO just saw everybody else doing it, so of course I've got to do it too. And you follow that up with this conversation between the CEO and HR. They didn't have a business problem, therefore they could not identify what the required skill sets were for the people that they were hiring. I would argue with you. I don't know if we have any data engineers in the room, but like data engineers are my favorite people on the planet. They did not hire in the right order. Had they hired, and there's probably a slide on this here, but the data engineers are the ones who go and get the data and make it such that you can make stuff out of it. They didn't have those people in place first, and so the data scientists came in too early in the process. Okay, yeah, this slide says exactly what I was trying to say, that the hiring was not done in an effective sequence. There was no manager yet. There was no business problem. There was no data engineers. The data was not in place. All kinds of bad things happening out of order here. Doesn't make sense to hire a team when you have no data. And yet I have seen this happen time and time and time again. Companies, naming no names, that recently had very lucrative IPOs have done this. Just happens over and over and over again. You do not want to hire a bunch of expensive data scientists and have nothing for them to work on. Okay, then there's this issue of data access and data governance. Siloing of data is one of the just hallmark signs that you have a problem with data culture in your company. Data governance, for those of you who haven't worked there, if you say the words data governance in a room full of chief data officers, you will watch them, go running for the hills, because this is the thing that makes them scared, is data getting to where it shouldn't get to, people having access to it that shouldn't have access to it. Data governance is something that needs to be in place from the beginning. Okay, so then you've got the data scientists and they come up with this idea, but again, they didn't have a business problem. We've had bad sequencing of hires. There's no real driver for what they came up with. They have no manager, they have no PM, they have no business problem. They're just trying to do the right thing, but they don't have any guidance on doing it. Then they create results, but again, they don't have a PM. So they're not necessarily getting relevant results. They're not solving relevant problems. They're not getting the solutions in front of the right people because they didn't have a PM to help guide them from the beginning. Okay, so let's talk about what this means for graph work. There's a perception out there, and I'm sure it's not a surprise to anybody who's in this call right now, that people sometimes think of graphs as a solution looking for a problem. Now, the biggest problem in this data fable was that there was no starting problem. There wasn't a business problem. It's complicated for graphs because, when we have graphy people, I don't know about you, but everything to me is a graph. Somebody comes to me and they say a problem, my brain immediately goes to a graph solution. Okay, and we have to avoid this being a solution looking for a problem here. We also have to recognize that the majority of companies that we are going to talk to, I feel this is different for newer companies. I'm working with some startups that are coming at this from a very different mindset, but at least companies with existing data functions, they've started with the relational database approach. They all have their own favorite flavor of SQL somewhere, and they're not thinking about things as graphs. They didn't from the beginning. And so now what they're looking at is we are that, the hammer here, seeing everything as a nail. And we're telling them, oh, now you need a whole nother database here, like a graph database. And they're saying, wait a second, now I've got the cost of maintaining two databases. So that means database administrators, that means the cost of the database themselves. And it's led to this perception that you have to operate at a very large scale to justify the cost. That it doesn't make sense to have a graph database unless you've got millions and tens of millions of nodes and relationships. So their view is this doubles the cost. Is it doubling the ROI? And then graph analytics is seen as a specialty. It's not seen as like a generalist data science tool. And so like when we were talking, when the CEO and the HR person were talking, they were talking about, what were the buzzwords? Well, they were talking about, at one point, deep learning was a buzzword. We're going to get to other buzzwords later, trust me. But, they were talking about all these buzzwords, but they didn't necessarily, even if they had a graph problem, they didn't know that they needed to be hiring people with graph expertise. I've worked places and I've worked with clients who absolutely have graph problems. I've led teams where I've said, this is a graph problem that, would be an instant solution, and the data scientists don't know how to use graph. This is an educational problem that I think those of us in this call really have an opportunity and almost an obligation to address. We'll get to that in a minute here. Okay, so here's just kind of a summary of what we just went through. We started with this idea of people, oh, I need to get people. And people are your strength for sure. You'll hear that from like any manager you talk to, but only if you hire the right ones. Which then after the people, we talked about the data. And, it's, you don't necessarily have the right data. Data just hoarding data doesn't solve problems, right? You have to have the business problem and you have to know what data you need to solve the business problem. But then remember, we didn't even start with the business problem. The business problem came in way later in this story. So data for the sake of data is a great way to waste money. What is it doing for the business? What business problems is it answering? What things is it unlocking? And it all comes back to culture. Understanding how data can solve problems is really where the story should start. But in reality, in this data fable, the CEO went at it exactly backwards. Or if you take this, true story, my kid is really into Stranger Things, and I was showing her this slide before Day to Day Texas, and she was asking what I was going to be talking about, and I was like, yeah, everybody's getting this backwards. She says, no, they're getting it upside down. Okay, so like if you're into Stranger Things, and there's this concept of the upside down. So I've been talking about this as the upside down approach to data, just because of my kid and her obsession with Stranger Things. What does this look like, though, if we do this right side up? Right side up means we start with culture, and culture, data culture starts from the top, setting the organization up for success. When you have that culture in place, that culture understands that data can solve problems. It understands how to identify which problems. Not all problems need data. Sometimes it's just a conversation with an ops manager to say, hey, where's the bottleneck here? But it's understanding how to find those problems that can be solved with data and what the return on investment is in doing so. Then what data do you have to go after to get at those solutions and where are the gaps? Maybe those gaps involve you having to buy data from some third party. Maybe it's just pipelines that need to be created. But once you recognize where those shortcomings are, then you go for the people. What people do I need to address those shortcomings? If it's the creation of pipelines, I need data engineers. I need data governance if I'm, collecting and storing all of this data. I don't actually hire the people working with the data until the data is in place. So that's my view. And again, this is the world according to me, and I'm really open to any, counter arguments to these things. This is my view, though, of the right side up way about going about data. Okay, so it started with data culture, and this is a nice little quote from Tableau about what data culture is. And, you can read that. It's behaviors and beliefs and practices and encouraging people to use data to improve decision making. Okay, it's a nice quote and all. This is getting at it a little bit in more detail. First off, it's a participatory sport. Everyone has a role to play in data. And it's not something that's limited just to the data scientist, because you have everybody who, if you have truly the right culture in place, the data product impacts every bit of the organization. This is not something that just creates itself if you're talking about an existing company. I'm going to leave startups out of this conversation. It's cultivated and it's grown over time, and it's a way of thinking. It's not just about tooling. It's not just I can go buy XYZ tool and it's going to fix everything for me. It's something that has to start from the top. Okay, I've never seen a cultural change in a company successful if the CEO was not on board with it. It includes efforts to level people up. You remember I said that a lot of data scientists, graph is like, that's a specialty, kind of like NLP or deep learning is a specialty. We need to get people out of that mentality. We need to have people understand that graph structures are just like any other data structure and just as useful. They are just as useful as a NumPy array, for example. So we need to change the narrative here that has excluded graph from being a standard structure in every data structures class that you take. I want to just jump down to this last bullet here. This is kind of the easiest way to identify, do you have a good data culture? Is when somebody makes an assertion, the next question is, do we have the data to back it up? And that question should be able to come from anybody within the company, from the CEO down to an intern. Do we have the data to back it up? Okay, I'm going to talk about the business problem here, and I want you to think about this. This is written kind of in a generic data way. I want you to think about the graph implications of this slide. Okay, so when I originally presented this slide, it cannot be answered with a simple SQL query. If this was something that, if the business problem could be answered with a simple SQL query, there is absolutely no need to have a data team. Grab yourself a couple really good Excel folk and you're done. Okay, the right business problem drives ROI, return on investment. And this has to be understood as being measured in many different ways. Dollars out, dollars out minus dollars in, that's a very simple way to do it. But there's all kinds of other measures that you can use. Does it reduce costs? Does it make faster time to market? Does it free up resources? Are you not dealing with the problems associated with security and compliance? So, understanding that identifying the right business problem has a lot of things that go into it. Did I make a slide? Yeah. Okay, so how do graphs come into play with the business problem and the data culture? First off, like I said, we need this community-wide effort to educate all levels on the importance and the benefits of linking your data. And like I said, everyone from executives down. The graph skills, like I said, should be a part of all data science curriculum. All data practitioners should understand the benefits of, and when it's appropriate, it's not always appropriate as we know, but when it is appropriate and therefore the benefits of linking your data. And then you can start thinking about tooling, whether it's a graph database or even just built in, like NetworkX and Python or something like this. seeking out the tooling to combat the cost and the ROI concerns. Because you remember, this is one of the biggest problems that we face when we're talking to people about graphs being a solution to the business problem. Okay, so I have this figure here on the right, and you know, this is just kind of a cutesy little diagram that I did not have Gen AI create for me of how data products, how data solutions get picked. And, you know, people will come up with these cute little figures looking at the cost and complexity on one axis and the business value on another axis. And obviously the sweet spot is low cost, high business value, such as in that little blue box there. And that's great. That's one way you could do that. That's a really kind of mediocre way of determining a data strategy, though, because there are some potential big wins here that are when you start looking at how some of the projects here, the projects are in green. So, you know, you're evaluating each project based on its cost and its business value. So just because something is outside of this sweet spot in the blue box, though, doesn't mean that it's meaningless. And this is where this is kind of like a secret thing that we can use as graph people to start getting, you know, those type of solutions in people's hands. Start looking at how some of these projects relate to each other. So maybe, you know, maybe we have a case where we've got, you know, there's this green circle. I doubt you can see my mouse here, but there's this green circle that's at the high cost, lower business value, but it's got something that it enabled, was enabled by this other green circle, this other project. So when you can start demonstrating the linkages of, yeah, okay, this one is higher cost, but its cost or complexity is significantly improved when you do that one that's within the blue circle. It enables this one that's outside of that blue. So being able to link those graph products to those things that are in the sweet spot, that gets graphs as part of the data strategy. Okay, so finding those linkages, I think, is really important for us. Okay, so gonna return this to today times. Maybe some of you know where I'm going with this one here, you know, saying, oh, my team needs data scientists. This was the conversation of the CEOs back circa 2015. But you might recognize this in today's times of, oh my gosh, everybody else is getting Gen AI. I have to as well. Okay. We've seen this bad story play out here. Boards are coming down. Every single company that is publicly traded, I am sure, has had to answer the question, what are we doing in Gen AI? And this is great for us, okay? This is great for us because we obviously have a lot of skills that are applicable to Gen AI, okay? Now, how do we take advantage of that? Well, first off, it's about education. You know, all the board members, okay, what was the first thing I did on ChatGPT? I went in and I said, give me directions from DC to New York in iambic pentameter. And wasn't that fun? It was so cute. Okay, great. That's what they all did too. Maybe not that exact example, but we all did the whole cute thing of, oh, what can this do? None of us, though, at that stage in our journey understood what it is to make a production-worthy Gen AI solution. And in this group, we know knowledge graphs are key. The retrieval augmented generation, RAGs, you cannot have a production quality Gen AI solution without RAGs, and graphs are the thing for RAGs. Yes, we can talk vector databases, but you know, there have been some really great studies showing that knowledge graphs are actually much more accurate than just a vector database on doing a RAG. Okay, so if somebody comes to you, if some manager comes to you and is saying, hey, Gen AI, let's go, and you say, graphs, we're there. All right, start with the business problem and metrics for success. So everybody wants Gen AI, but first off, what problem is it solving? You know, maybe it's decreasing cost because, you know, some company can start downsizing their call centers. Maybe it's taking software that, you know, one of the examples that I like to do as being a really great use case for Gen AI is commercial banking. Okay, commercial banking is based on 93% of ATM transactions use COBOL. Now, if you don't know what COBOL is, I don't blame you. It's a programming language from the 1960s written by the Department of Defense for mainframe computing. Okay, nobody knows COBOL anymore. Nobody teaches it. The software engineering principles are decades old. And we have the entire international global banking system based off of software that nobody knows how to maintain. Here is a great use for Gen AI. Gen AI is good at summarizing stuff. So instead of taking, people who are straight out of college who've never been taught COBOL, and by the way, if you've ever looked at it like, oh my gosh, okay, they're not being taught COBOL, they're not being taught those software engineering principles. You give them like stacks of manuals that are, these manuals were not written by people who are retired. They're written by people who are now dead. That's how old this stuff is. And there's thousands of pages and we're saying, here, go figure it out. No, don't go figure it out. Use Gen AI for that, okay? Next one here, do not be the hammer looking for a nail. So we don't want to be, graph. What we want to be is solution. You want Gen AI, great. We need RAG because RAG is what makes Gen AI work, okay? And then demonstrating the need for graphs as part of the solution means that you have to be able to demonstrate performance improvements with your LLM. What that means is that you have to know how to evaluate an LLM. You need to get into the tools to understand things like contextual accuracy, correctness. What does correctness mean? And how are these things evaluated? So, being part of the LLM side as well as the graph side is really super important here. A lot of work to be done here. I do confess to a lot of skepticism that if you know the Gartner hype cycle, I worry we're at that peak of inflated expectations and we're about to have this bubble burst where everybody's going to be like, whoa, I can't generate any ROI from this. This is too expensive. I don't know how to make this work. If you can be a person who's the part of the solution for solving business problems and generating ROI, you will be successful as a graph person. Your team will be successful as a graph team, just in this small niche, okay? But right now, this is where all the attention is. So with that, I have this slide in here from Satya Nadella about data culture. You can go through and read it, but I really do like this quote because it's talking about every team and every individual being empowered through data. So we want to think about every team and every individual being powered through graph data. With that, just want to say thank you again, Amy. Thank you, Dennis. Please feel free to reach out to me on email, LinkedIn, wherever you like to have digital exchanges. And I am going to stop sharing now so I can see people and answer any questions or discussion. So thank you.
All right. Thank you, Claire. That was terribly entertaining as well as educational. I got to say, I'm unmuting people now, so we'll give them a moment. But I got to say, I also like the pictures. So the little crying data scientists I thought were awesome, and unfortunate that they're crying, but hopefully that will improve over time. But there are a couple questions that I added to the Q&A. So why don't I just go ahead and read those? There's just a few, but the first one actually comes from me. Watching the early slides. Hello, we have some people popping in the video. So the first question was thinking about what you're advocating, the approach of being data culture driven first and then looking at the data and kind of walking down that path isn't really new in the software product technology space. But for some reason in the data science arena, in the Gen AI and the graph and the anything new arena, that's not really, it's almost like we're starting over from scratch. And I'm just wondering if why you think that is handled so differently, and I'll just say poorly in the data science realm. What have you seen?
I think it has to do with speed. And Gen AI is the perfect example of this. People are moving so fast and furious. They don't have time to wait. We need this now. My competitors had it yesterday. And so there is just such a drive to get something out the door quickly that they're not stopping and taking a step back and asking the right questions. Now, there are places that I think might actually be doing this right in Gen AI, for example, and that would be places like fintech, places that are more conservative. There's so much FOMO, fear of missing out, but fintech, they have some serious laws that govern what they do. And so a lot of fintech companies are taking the wait and see approach. And I think that's justified, and I think that's right. They are not going to be the ones who waste a lot of money and have nothing to show for it. They're going to wait and see what happens and who percolates to the surface, surviving the popping of the Gen AI bubble. But I think the same was also true, in the early 2010s was, there were some really quick wins that companies had with some low-hanging fruit involving data science and machine learning. And then everybody freaked out that, oh, geez, I'm losing business. My competitors have a huge advantage over me because they did and I didn't. So it's all just, to me, how fast these things are moving. And Gen AI is moving 50 times more fast than data science was.
That's a good point. Some other, so I think that's really helpful to think about that in the bigger context as well, and maybe look at patterns that we've seen in other areas that hopefully we'll see maturity in these areas as well. Another question is whether what your thoughts are, and this is rather specific, on graph and vector databases converging, and will they, should they, what does that imply? Yeah, I know that's a big kind of what if question, but there you go.
Yeah, it's funny because I don't know if anybody here attended any of my content for Neo4j a couple of years ago where I was talking about knowledge graphs and natural language processing. And what I had done at the time, although we never did anything with it, it was going to be the subject for future courses, I was putting vectors as properties within the graph. Now, I wasn't doing vector indexing within the graph, and my understanding, I haven't tried it, but my understanding is Neo4j can do vector indexing now. You've got the pine cones of the world and Weaviate and all of that. You can do it in Postgres. You can create vector databases in a relational database, and that's great. My gut feel, and this is just my gut feel, I have not proven this, is that the combination of graph indexing and vector indexing. So now you've got two means. You could have a graph vector, just NodeDevec or something like this, or FastRP, combined with a word vector. And my guess is there is huge power in doing that. So if somebody does that, will you please let me know how it goes? Because I think it would be amazing.
I think we've been, some of us have been poking around and just seeing if anybody's going to be doing that, because that's, I agree with you that the combination could be quite impressive, and I'm kind of waiting to see somebody do that. So agreed, yes, definitely tell us if somebody is doing that. Dennis, it looks like you had a question. Do you want to go ahead and voice that? And just, if I've done it correctly, people should be able to speak as well. So Dennis, yeah, if you could voice your question, that'd be great.
Thank you, Amy. Thank you, Claire. So my question is, when adopting a graph thinking approach, how do you ensure fairness in selecting the best solution for a problem? While graph can be applied across various domains, not all problems are best solved using a graph-based approach. How do you navigate this balance effectively?
Yeah, it's just like anything else in software engineering. I think you wouldn't use .NET to solve a data science problem, right? You wouldn't necessarily use a graph to solve a logistic regression problem. Just something that there are problems that are well suited to graphs and problems that are not. There are problems that are well suited to certain programming languages and problems that are not. And so it's about identifying the where are the graphy solutions? So if the business problems to be addressed, those are, here's the corporate strategies for the year. Here are the things that we're trying to put into the product this year. Here's the product roadmap. And, as those things percolate down through the ranks into the data organizations, it's about recognizing where those graph problems are. I'm not going to name names, but having worked for a company where they were trying to implement a recommendation engine. Now, like I said, my brain always goes to the graph solution, but I mean, come on, like recommendation engines just scream graphs, right? And I have seen some, and it's actually been with multiple companies, so it's not like I'm even pointing at any one particular company. I've seen multiple companies do recommendation engines really poorly and get really horrible results, and then start, flogging the data folk about get these results better. And it's all because they didn't start with the right approach, the graphy approach, because they just didn't know, and then, when on the rare occasion where they're allowed to then go and redo these things and they realize, look at, my A/B testing shows my graph solution was so much better than, the regression solution or decision tree or whatever, it's just, the proof's in the pudding, but it's up to us to start, helping the data science generalist realize that graphs are the tool of a generalist. Recommendation engines, go on to LinkedIn, get 1,000 data scientists, and I am willing to bet at least 3/4 of them have had to make a recommendation engine somewhere. And yet I doubt 3/4 of them have graph expertise.
That makes sense.
Thank you. And I guess I'll ask if anybody wants to unmute. I know some of you are listening, but on mute. This is a great time to unmute and just jump in with a question if you have it. Pausing.
Hi.
Hi, Katerina.
Hi, how are you doing? Yeah, I had one question. First of all, Claire, it was an awesome talk. I really enjoyed the table. It was so fun. So I love the part where you explain where that teams don't have an actual problem defined well, so it's hard for them to try to find a solution. And you did mention SQL. So I noticed a lot of people switching from SQL to graphs. So I was wondering how to kind of bridge a gap from SQL people not being able to define a problem well, and then potentially later reaching to a graph as a potential solution. Should we focus more on educating SQL people who kind of maybe don't have their solution, or just go straight to the explaining for which problems the graph is a solution, if you get my point? So
yeah, totally.
There is a kind of, yeah,
and I mean, data scientists have to be really good in SQL, right? And are trained to think in a relational database way. Some of the most common tooling for data scientists is things like pandas, which is, is just relational database in memory for Python. And so it's hard because this is just how their brains are wired, right? And then you tell them, yeah, and then on top of all of that, you're going to have to learn a new query language too. Whether it's, Gremlin and Groovy, or it's Cypher or whatever, you're going to have to, because NetworkX is nice and, nice and Pythonic, but it's only going to get you so far. And, these things that, these business problems that need data as their solution, probably NetworkX, you're not going to get very quick answers out of that. So it's challenging when you add on the complexity of having to learn another query language as well. And I heard that so many times in my career as I've tried to introduce graphs to people. And I mean, I will be critical of Cypher. I don't think Cypher is an easy query language to learn. It certainly has a lot more, in my opinion, these are hot takes, so, in my opinion, it's more powerful in the long run than something like Gremlin, but you're still talking about a very different query language. So then, getting people to recognize that it's a graph problem, maybe the better idea isn't to get them into that space of, oh my gosh, I have to, learn this new query language. I mean, maybe I do, maybe I don't. I have to have now 2 different databases. I'm going to throw a shout out here for PuppyGraph. Anybody use PuppyGraph? I don't think there's any PuppyGraph people on the call, are there?
I don't believe so, but several of us are familiar. But
yeah. Okay, so like to me, if this works out, this is a game changer. Like, you know, this will truly open up graphs to a much broader group of people who should have been using them all along, but you know, they have that resistance of, you know, I don't want to have to maintain another database. I don't want to have to, you still are going to have to learn, you know, Gremlin or Cypher to do it, right, with PuppyGraph, but you've just taken one of those hurdles away from them. So I think tooling like that is really powerful. But ultimately, you know, it's still, you still have to get back to that place of helping them see the connectedness of their data. And the way that I have done it that has been very effective, I think, is just showing side-by-side queries of SQL and Cypher. And, you know, I tell people, if you've got more than like a couple joins in SQL, you're really dealing with a graph problem. And let's be honest, you've got more than a couple joins in SQL, you're getting slow anyway. So let's go to a data structure that's designed to handle that.
Thanks. Yeah, I agree, definitely.
As a fun one, I did, I had this series going called Bite-Sized Neo4j for Data Scientists. It's like, it's over 30 little videos now. I stopped making it when I left Neo, but one of a little series within the series I did was comparing SQL and graph, and I did PageRank, both in Cypher as well as in SQL. And like, if that doesn't convince you that you want to use a graph database, nothing will.
Also,
so Claire,
recommendation engine, Annie, that you mentioned recommendation engines for quite a time. So I think that's also a really good example when you have side by side and you get complicated in SQL. But with Cypher and all of the relationships, I think it gets, I mean, it's quite simple.
I worked on the recommendation engine that GitHub uses today, and it was done in Airflow and it was done with SQL. And I am not kidding you, this DAG, geez, it had to be 200 steps long to do it. And it would have just been like just this trivial query in Cypher.
Yeah.
So I'm imagining this other webinar topic, or maybe it's a blog post or something of that nature with multiple contributors. But I have this vision of how to get your graph project approved, or how to get funding for your graph project, because I think that's a whole other adjacent, but maybe a whole other topic here.
If you go into the slides, the one that has the cost versus the business impact, there's a reference there to a Harvard Business Review article. And it's a whole article on how to get data projects approved. And it was the one that was talking about, connecting the stuff that's higher cost to the stuff that's lower cost. So it's a great article. I really encourage everybody to read that one. I was just doing a poor job of it at that. But.
Awesome. All righty. I have just a couple wrap-up questions, but I want to give a moment in case anybody else has questions that they want to voice or put in chat. That's fine too. Oh, awesome. Yeah. Andreas.
I can try to say my question, because it's about the culture. It's not all alone about data culture. It's about cultures in many perspectives, because I'm at my second job chance, you can say, where I'm using graphs, and I've been using graphs for 4 years, and this is the second time that the decision makers don't understand the return of investment and is taking it down. The what do you say? I don't know the word, but they don't understand how it will give them money back, and this is a big problem, and I don't understand how to convince the decision makers, and that's my question. How do we do this?
Yeah, it is not easy. It is very much not easy. If it was, we would all be, you know, rich beyond the wildest dreams of avarice, right? It's, you know, understanding how the business leaders identify success. Some business leaders, you know, they look at KPIs. Some of them look at revenue. And I mean, you know, this can change depending on the problem and whatnot. And understanding how to relate our problems to their particular metrics. And, you know, I don't know if Gen AI is in your future or not.
I think so. Yeah.
You don't think so?
Yeah,
you
I think
do.
so.
Okay. Yeah.
I haven't had the time yet.
Yeah. Just, you know, being able to show the improvement in metrics and relating that back to user adoption. So if something is giving you the wrong answer all the time, you're not going to use it. If it's hallucinating all the time, you're not going to use it. And it's, me, one of the best examples of graphs as a return, because there is nobody out there who is doing any sort of Gen AI that is successful without it being backed with RAG. And oh my gosh, Amy, I'm blanking on his name. Who was it that did the talk at Day-to-Day Texas on knowledge graphs for RAG versus anything else? What was that talk?
Oh, you don't test me on memory. We will add it to the Discord server for GraphGeeks for folks to follow. Yeah,
it was brilliant, and it was, you know, the title was something like "Knowledge Graphs Improve Your Gen AI by accuracy by like 33%." And I mean, I went into the talk and I was really super skeptical. Like, you can't. How are you going to quantify that? Like, what's really, you know? And by the time it was said and done, he was doing something where it was trying to have the Gen AI write SQL queries, and it was looking at a few different metrics of those queries. And by the time it was said and done, it was an incredibly well done, well reasoned approach. And absolutely, his numbers, you know, he had a very defensible and repeatable way to show a 33% improvement in accuracy using a graph. And so I thought that methodology was very powerful. And I'll go find it. The paper that he published, it's out there. It's in the public domain, and we can drop it into the GraphGeeks. It's probably already there, and I'm just going to have to resurface it or something. It was brilliant. So when you can take things like that to management and like, don't get super technical with them. Say, you know, this is the technique that everybody is using to get rid of hallucinations and make LLM output more accurate. It does really speak for itself, I think.
Yeah.
Well, we'll go ahead and start wrapping up. We try to go about 45 minutes, but I think this has been just a really wonderful discussion. Claire, thank you again. Two wrap-up questions that I like to ask everybody. One is, what in the graph space right now, what do you see as the biggest challenges for either the adoption of graph or continuing projects or getting into production, as you say?
So, you know, it's cost. It's the cost of having somebody to maintain the database, and somebody, the cost of the database itself. Those two things for me.
So acquisition and maintenance, awesome, or not awesome, but good answers, and I like that focus again on the adoption bit. The second question that I like to ask everyone is, what are you most excited about in the graph space right now?
Puppy graph.
Okay.
Yeah, no, I'm super excited about puppy graph, but you know, not necessarily from it as a like as technology, but from what it's going to do to enable people. I look at the number of people who will now, you know, have the opportunity to start considering graphs as a solution. You know, oh, gee, because we took that one problem away from them, the database problem. My data's already here. Why do I have to, you know, keep, you know, my data's on a daily update cadence, and so now I have to daily update my graph too, and oh, that's such a pain. And maybe you don't. Maybe this really does work, and I have not had an opportunity to poke at it too much. I've used it a little, but it's going to make people rethink how they implement graph solutions within their company, and that's why I'm excited about it.
Great. And I will say the idea of what's old is new again is also this idea of a graph engine, which is separate from the graph store, is kind of not necessarily a new idea, but it's new in the last probably 10 years. We haven't been talking about that. So it's kind of great to see ideas and the potential to implement different types of solutions for different types of problems when you don't necessarily want a separate store. So great. Well, again, everyone, thank you for joining. Thank you for the really great discussions and engagement. I always really appreciate that. Claire, as ever, clever, very helpful, very practical advice for us. And if you you know, hopefully you'll be able to come back again at some point and, you know, share other learnings, you know, throughout the year, and especially as this whole space evolves and we can all learn from you.
Absolutely. Thank you again for the invite. Thanks everybody for coming. It was great seeing everybody.
Thank you.
All right. We'll see you all on GraphGeeks.
Thank you.